In today's lesson, we're going to start making dot plots and frequency tables. Dot plots and frequency tables are used to be able to find what value occurs the most often. So if we look at the definitions, a dot plot is a number line that marks the show of frequency. Frequency is the number of times data occurs. So make sure you highlight these definitions first. Then we'll take a look at the question. It says Hannah is training for a walkathon. The table shows the number of miles she walks each day. She has 1 day left in her training. How many miles is she most likely to walk on the last day? So we're going to create a dot plot, and then we're going to use that to answer the question. Again, a dot plot is always also known as a line plot. Usually with line plots we use X's instead of dots. And I think we've done that. I've done that before on the PMTs. So first, we're going to draw a number line with an appropriate scale. That means where the numbers begin and where they end. Okay. In this problem, the numbers vary from 1 to 9. So we're going to use 0 to 10. We always want to use a scale where it includes all the numbers in our data. Okay, we wouldn't want to go 1 to 5 if we have a number 9 because it wouldn't be on our line. Okay. Since for each piece of data, plot a dot above the number that corresponds to the number of miles Hannah walked. Complete the dot plot by making the correct number of dots above the numbers 5 through 10. So they already did this 1 through 4 for us. If you look at the graph on page 459, it already did 1. There's 1, 1. We have, so if you look at it as 4, so there's the first 4. 2, 9, which is the next number. If I'm going right to left, so I'm going to put a dot there. 3 is that one. Another 3. 5, so I have to put a 5 there. Another 5. That goes there. 1, so that's that one there. 6, so I'll put a dot there. 2, so there's another one here. It's already done for me. Another 5. 2 is already done for me. Another 5. 4, which is done for me already. Another 5. A 4, which has already been done for me. Another 9, so that goes here. 3, 2, and 4, which all have already been done. So when I'm done, my dot plot looks like this. This is a completed dot plot. So that's step 2. And then step 3, the number of miles Hannah walked most often is the value of the tallest stack of dots. Tallest stack of dots here is 5. Because she walked 5 miles 5 times, which is more than any other distance that she walked. She only walked 4 miles 4 times. She walked 2 miles 4 times. She walked 5 miles 5 times. So that's the answer to that question. Okay. So the number most likely to walk on her last day, the answer is 5, because if you assume somebody does something the most, you assume most likely that they're going to do that again. Now, it could be different, but they're saying based on she walked 5 miles 5 times, that's what's most likely to happen the next time. It's because it happened the most often so far. Okay. Now there's a couple more definitions at the top of page 460. It's a frequency table. It shows the number of times each data value range value occurs, and a relative frequency table, which shows the percent. So that's the difference. So make sure you understand the difference. Relative frequency has percent in it. A frequency table just shows the number of times. And basically a frequency table is a line plot put in a table format. So we're going to look at that next. So if you notice here, it says Jill kept a record of her workout times. How many of Jill's workouts lasted exactly 90 minutes? Well, here The nice thing about this is there's no range. It's just 30, 60, 90, or 120. That's your choices. So we put that here in our table, our choices, and then we're going to count how many times each one occurred. So in 30, we see 1, 2, 3, 4, 5, 6, 7. So there's 7 times that she did 30 minutes. If we count 60, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I believe it's 10. So let's take a look and make sure we're correct here. 11. I missed one. I must have missed one. So if we look at that, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 times. If we look at 90, it's 1, 2, 3, 4. According to me, I think it's 4 times. Yep. And then 120 would be 1, 2, 3, 4, 5, 6. 6 times. So that's how you create a frequency table with using just the numbers here. And some frequency tables are different. We'll get into that in a moment. So if we look at the question, it says how many of Jill's workouts lasted 90 minutes. The answer is 4. So moving on to the second example, relative frequency table. This is where we're going to find the percentages. The relative frequency is the percentages. So if we look at this question, it says, the table shows the number of laps Ricardo swam each day. What percent of the days did Ricardo swim 18 or more laps? So keeping the table here, we're going to count the number. The hardest part about some of these frequency tables is the range, these intervals. And you want it, they have to be the same. And we're going to talk about this a lot in class because this is the most difficult part of frequency tables, is finding these ranges. Okay? They are the intervals, finding the intervals. They have to be the same. So notice this one is 5 numbers, 3, 4, 5, 6, 7. That's 5 numbers. So there's 5 numbers in this interval. There's 5 here, 8, 9, 10, 11, 12. There's 5 here, and 5 here. So what we have to do is divide equal frequency by the total number of data values. So what that means is there's 20 numbers, and you divide it by 4, and that's where you get the 5 from. Okay, and but here what they're talking about is 6, there's 4 frequency. This happened 4 times. You divide it by 20, or you get 20%. This is going to be 35%. This is going to be 15%. And all your percent should add up to 100%. Okay, what I need you to do is to answer the question on page 459. Okay, on Edmodo. The answer is 15%. We'll talk about this some more because I know I rushed it and I have to go. So